Welcome back. This is example 1 for today's lesson on graphing quadratic functions, okay? So let's start off. I did add a table to the notes, so you might want to do that on the side. And you have a little graph on yours, so we should be good. And I'm just going to go ahead and put some values in, make sure we're good with that. My first value that I'm going to put in, -2. I'm going to put in -1, 0, 1, 2, and 3. I'm going to go ahead and plug in my values and calculate what y is. Use your calculator or your brain. -2 squared minus -2 minus 2. Okay. Now, if you have any questions, I definitely recommend that as we're going through these, that you put little questions on the side, maybe post-its, maybe just little marks, and that you definitely reference your notes and ask me questions later. Here we have -2 squared, so we end up with +4. We have +2 and -2. And when we add that up, we should end up with a y value of 4. Okay, so again, here we go. And if you find any errors, please let me know. We'll make it like a scavenger hunt. Okay, just plugging it in. We'll go ahead and do the same for all of them. Once we have our positive numbers, though, we don't have to use the parentheses as much. We can kind of just pop it in, like 1 squared minus 1 minus 2, and 2 squared minus 2 minus 2, and 3 squared minus 3 minus 2. So all we're doing is that. Let me go ahead and do the work. So of course that's +1, +1 minus 2, which is 0. Okay. And here, that's 0 minus 0 minus 2, -2. 1 minus 1 minus 2, -2. And here we go with 4 minus 2 minus 2, which is just, make sure. Okay, yeah, 0 again. Okay. Are y'all seeing a pattern here? See how there's probably something kind of symmetrical where everything's the same on both sides of this? Yes, just kind of looking forward. We have 9 minus 3 minus 2. So 9 minus 5 is just 4. We have that. You probably could have predicted that, right, at this point. So let's go ahead and let's put some dots down. See if it lets me do some pretty dots. So I'm going to go ahead and put in -2, and then going up by 4, dot, -1, 0. We've got 0 down 2. Okay. And I got 1, -2. Probably made my dots a little too big, but oh well. And then 2, 0, and 3, 4. Okay. Ladies and gentlemen, when we draw our line, it's going to end up looking like this. So I'm going to go ahead and start up here. And I'm trying to be really like pretty good about this. Of course, we know it's a graph. It's not going to be perfect, right? And there is our parabola. Okay, so the idea is that we want to state our range. Now, is -2 really the lowest value? I mean, because this technically is -2, right? But notice how it goes a little bit lower. So if I wanted to find the exact amount, if I want to find the vertex, what is the minimum? I know it's going to be, what is my x value going to be? It's right in between these two, right? So here, x is 0 and x is 1. So if I'm looking for something right in between, probably 0.5, right? Or 1/2. And I can actually like do the math where I had to say, okay, you know what, x is going to be equal to this, and I plug it in. I guess I could scroll down a little bit. Let's see. Let me go ahead and do it down here. So I've got 0.5, and I'm going to go ahead and do the work. I've got 0.5 squared minus 0.5 minus 2. And when you do the work, you end up with an answer of negative 2.5. Okay, so that point right there is actually zero point 0.5 negative, oh, I forgot the decimal, or I didn't even make bigger, negative 2.5. So again, when we're identifying domain and range, first of all, are we going to be listing out the individual numbers, or are we using inequalities? And the answer is inequalities. This is a smooth and continuous line. And so when we talk about the domain, we're going to be using inequalities. What variable is domain all about? X. Very nice. And we don't have any open dots, so we always include less than or equal to. So let's look at our x values here, right? Our smallest x value was negative 2, and our largest was 3. Do I stop at negative 2, or does it keep going? The answer that it keeps going, absolutely correct, because of course we have arrows right here, meaning it keeps going forever and ever and ever. So this is actually like negative infinity. And then we keep going forever and ever in the opposite direction, so that's positive infinity, meaning that our domain is actually all real numbers. Okay? I'll do my little symbol. Okay? That is the domain. Let's go ahead and look at range now. Okay? We're looking at our highest and our lowest. We'll do the same thing here. So, of all these numbers here, which one was the smallest number? It was negative 2.5. So that's actually the lowest point here. Let me go ahead and okay, we're going from our lowest to our highest. And range is all about the y-axis. So we're looking at where does it hit on that y-axis. And so the lowest point is negative 2.5. Okay, and my biggest value, well, I mean, on our table it says 4. Does it get larger than 4? Yes. Does it get larger than 6? Yes, because of the arrows, right? So that's going to be positive infinity. So the truth is that we're only going to be focused on this part right here, right? I'm going to rewrite it so that y is on the left. And I got negative 2.5. And it's in essence pointing to the negative 2.5. So we want to make sure that it keeps pointing to the negative 2.5. And this is our range. Okay. So our range is y is greater than negative 2.5, and we have all real numbers as our domain. And I'll put a little d here. All right, let's go ahead and let's look at another one. Example number 2, we want to find the vertex, the equation of the axis of symmetry, and the y-intercept. So first of all, the vertex right here is either the tippy top or the very bottom, okay? So what I'm going to do is, that's our very bottom. It's definitely a nice minimum. Of course, they didn't ask for that yet, but okay. And so that vertex is located at, go ahead and do this vertex. It's an ordered pair. It's a point. And so we have 2 and negative 2. Okay. The equation of the axis of symmetry. This is a line that's going to look like this. Let's see if I can actually draw it straight. And it's kind of like what divides it right in the middle. And if you noticed, I actually ran over a number, and that number was 2, right? So that's your axis of symmetry. Now it's a vertical line, okay? And that means that the equation must be, it's undefined, it's the one that breaks all the rules. So it's actually x equals 2 is my line, right? So I'm going to abbreviate. The axis of symmetry is x is equal to 2. Now, when we talk about working smarter, not harder, could I have looked at the vertex and be able to determine the axis of symmetry? Yes, because look, what does x equal? 2. X equals 2. So if you know the vertex, you know the axis of symmetry. Really easy. And then the next is the y-intercept. Okay? The y-intercept, what is always equal to 0 at the y-intercept? Always. X. Very good. It's always the opposite variable. Like if it's the x-intercept, y is equal to 0, right? And you can actually look at the graph and say, oh, where is it touching the y-axis? Oh, it's touching it at 2. And so that right there, the y-intercept is 0, 2. Okay? Questions? Make sure you write them down. Let's go ahead and let's look at the next example here. All right, right there. Find the vertex and the equation of the axis of symmetry and y-intercept. So if you wanted to, you could totally pause the video and then just see if you can do it, and you know, and then you'll know you're kind of good on this, right? If not, you might want to go back and listen to the explanation. So here we are. We have the vertex. It is the very tippy top. It's actually a maximum at this point. Okay, and this is the point. So when I say the vertex, we're looking at the point of 2, 4. Okay, it's just the coordinates of this point. Now the next thing it says is the axis of symmetry. Well, axis of symmetry is a vertical line, right? Which means that the equation is always x equals. And what does x equal? It equals 2. It equals 2. Okay, last but not least, we have the y-intercept. Where does it touch the y-axis? We always know that what is equal to 0? The x at the y-intercept. And we look at our graph and make sure, I'm thinking -4. So let's go ahead and write that down. All right. Let's keep plugging along here. Let's go with next one, example number 3. Find the vertex, the equation of the axis of symmetry, and y-intercept for this. Woo, okay. So with this one, I think before we get started, we need to know one thing. There is a formula here. The formula for the axis of symmetry okay, we're going to pretend the principal symmetry is x is equal to -b over 2a, right? So let's go ahead and let's look at our equation right here. We're going to identify what a, what b, what c is. So a is -2. Good job. B is -8. And C is -2. Remember, it was the formula was like ax squared plus bx plus c, right? So when you identify what a is, it's whatever's in front of x squared, whatever's in front of x, and whatever's in front all by itself. There's your a, there's b, and there's c. So now that we know that, we can plug it in, and we're going to calculate that our axis of symmetry is, I got -8. Remember, always, if there's a negative there, you leave it there, right? And then you're replacing b, and you replace b with that -8. That's probably one of those tricky areas where people would make mistakes. And then 2 times a, so I plug in -2. Okay, we do the math. Negative times a negative, positive, and 2 times -2, -4. 8 divided by -4 is -2. This is what x is equal to. This is our axis of symmetry. So let me go ahead and write that really nice. Axis of symmetry is x is equal to -2. So now that actually tells me about another part of our deal that we need to find out here. So it's actually part of the vertex, remember? because of the axis of symmetry goes to the vertex. So if we know that x is equal to -2, where am I going to put my -2? Where x should go, right? So now I need to use, we're going to go ahead and kind of create another little section right here. I'm actually going to plug it in and calculate what y is. So I've got y is equal to -2x squared minus 8x minus 2. I know what x is, so I'm going to plug it in. Okay, so we start with our exponents first. That's got to be +4. Okay, let's scroll down a little bit. Ooh. All right, -8, +16, minus 2. So that ends up being 8 minus 2, which is 6. I'm going to plug in 6 right here. Okay. Now, the next thing that we need to identify is the y-intercept. No problem. What is always equal to 0 at the y-intercept? X. So all I'm going to do is same thing again. I'm making a little section right here. And I'm going to plug in x being equal to 0. Or if you remember, let's see. So here we've got 0 squared. Oops, put a 0 there and that. So all of this just goes away, right? It's just 0. This becomes 0. And basically what we're left with is -2. Now, what would have been a smarter way to identify the y-intercept? Just by looking at the equation. Right? If you said, hey, it's just the constant at the end, you're absolutely correct, right? The y-intercept is the constant. It's basically c, right? So I would make a little note. Maybe next time I don't have to do all that work. Y-intercept is equal to c, right? So if I had to learn two things, maybe this one and this would be really good, right? Okay, so I think let's take a little bit of a break on that one, and we will wrap up the rest of this probably Thursday, I believe. So today is Tuesday, right? We're gonna have a little practice session tomorrow, and then we will practice. Then I'll introduce some new things on Thursday. Okay, stay healthy. Take care of yourself. Bye. The notes, if you actually printed out my notes, you might have to write pretty small, or you might just want to write this out on paper. It's up to you. Um, it's going to be quite a bit of writing, so just kind of keep that in mind. All right. Let's start with 3b. Find the vertex, the equation of the axis of symmetry, and the y-intercept of y equals 3x squared plus 6x minus 2. All right. So the first thing let's start off with is, I think, honestly, the easiest part right here is the y-intercept, okay? So if you recall, the y-intercept is always the same as c. What is my value for c here? Because remember, it's something like this. It's like ax squared plus bx plus c. So c actually has a value of -2 in this case, yes? So when we're writing this out, this is going to be the y-intercept, and I'm going to write it as an ordered pair. So the y value is actually -2, and x is 0. Okay, that's good. Let's go ahead, and I'm going to make like a little area right here of our different answers. So we wanted the y-intercept. We've got that. And the next, let's go with the axis of symmetry. So there is the A dot OS. There is a formula for that. I switch colors here. The AOS has a formula. X is equal to -b over 2a. Okay. So when we look at our equation, What is A? Good, 3. And what is B? 6. Be sure that you are always including the sign. So remember when we had C, we must include the negative in front of it. So here we go. Let's go ahead and let's just identify. We know that A is equal to 3 and B is equal to 6. So I'm going to plug that in. And in this place, I'm going to put B, 6. And in this place, I'm going to put 3. So we end up with negative times 6, negative 6. And 2 times 3, which is just 6. Negative 6 divided by 6 is negative 1. So we end up with our axis of symmetry. The equation is x is equal to negative 1. Okay? And if you recall, if we have something like this right here, the axis of symmetry is actually the line that just divides it right down the middle, okay? We'll pretend that that's a vertical line. So that would be the equation, x is equal to negative 1. Okay, let's go ahead and let's do our final one where we calculate what the vertex is, okay? So I'm going to go ahead and put another line in here and kind of block off a little area right here, okay? So here's our vertex. So we can actually pull from one of these two. We're looking for this point right here, right? Notice how the axis of symmetry will always go through the vertex. So it will always tell us what our x value is. So right now we know that x is actually equal to negative 1. And we just have one last thing to do, which is to solve for y. So we're going to start off with our original equation. We're going to go ahead and put in parentheses everywhere there's an x, especially when you have a negative sign, because that's just like number one area that people make mistakes is that they just mess up with that negative. So here we are, we have negative 1 times negative 1. That's the same as negative 1 squared, right? So negative 1 times negative 1 is 1. So that ends up being 3 times 1. And 6 times negative 1 is just negative 6. And then we have negative 2. And of course, that positive times a negative is a negative. 3 times 1 is 3. We're just going to combine all of these things here. We've got 3 minus 6, negative 3, negative 3 minus 2, negative 5. So our y value, when x is equal to negative 1, will equal negative 5. We plug it right here, and we have everything that they asked for. I will learn how to draw straight lines, I promise. And there we are. Okay, make sure any questions you have, you do write it down, and that you bring those questions to me. Okay, let's go ahead and let's look at the next example, example 4a.